previous demonstration, we were looking at the project, Avionics Passenger Counter. Now, we're going to step down inside that project to look at the hardware and software items that comprise it. But before we do that, let me just give a quick reminder about the PACT hierarchy so you understand what we're doing and how the tool operates at these two distinct levels. So we looked at the project, our Avionics Passenger Counter, and at that level we have the system requirements. We have a roll-up of the problem reports for, basically for the project itself and all of the subcomponents, those hardware, software items, and the review status for the hardware and software items. We also have the ability to archive the project. Now we're going to step down one level deeper. A lot of people might want to call these themselves projects because there'll probably be a project team working on each of them separately. For example, you might have a hardware team that's working on the circuit board, another hardware team working on the FPGA, another hardware team working on the software module, as we're showing in this picture. But we use the term item here to distinguish that. The term item comes from ARP 4754A, which is the regulation for airborne systems, so we try to stick with that same sort of terminology. At this item level, we're going to have a number of objects and activities that we deal with. First of all, documentation. We'll take a look at that. Then we have requirements, which really are a way to capture the functionality of these hardware and software items. The terminology in this area differs just a little bit. Again, we try to stick with the industry documents and use the specific terminology for hardware and software here, so there's a little bit of a difference. For hardware, we use, for the highest level description, we call that a requirement, and for the next level down, we call that a conceptual design description. For software, we call them high-level requirements and low-level requirements. If you are doing model-based design, there will be model files. So between the requirements, the conceptual design, the model files, these are all ways to capture descriptions of the functionality prior to actually implementing them. The implementation occurs in the code. Source code is typically the term used for software. It might be HDL code for hardware. We use the term source code within PACT to cover both. Then there'll be the test cases, which actually describe the criteria for testing a requirement, and test procedures, which describe how to run those test procedures. We'll have problem reports that will be filed both on objects related to the development and the process itself throughout the process. Then we have something called an RTM, or Requirements Traceability Matrix. I'll talk about that more as we're looking at the requirements and how those all link together and define the project through the functionality that's described and how that's implemented. So we'll talk about that more. And then there's reviews. Reviews fall into two categories: peer reviews. Peer reviews are for documentation and artifacts of the process, and transition reviews are for actual steps in the process. So in this next set of demonstrations, I'm going to be looking at each of those, taking you through them all individually. But for the moment, let's jump back to our hardware and software items at the highest level. So if we click here, we're going to be down now inside of, at the all projects level, we're down inside of our avionics passenger counter, and we're now at a hardware and software items list. Just like every other list, every row is a specific object. In this case, it's the hardware or software item. And every column is a specific field with information about that type of object. In this case, we have the name. We have an identifier, or kind of a shortcut for that name. We have the type of hardware and software item, the level, or design assurance level, DAL, and then we have a bunch of things that fall under navigation, which are objects or activities to be performed. Let's look at all of the hardware and software items that comprise the avionics passenger counter. We have a controller board, which is hardware, subject to DO-254, and it's DAL-A. We have an A-Ring 429 FPGA, also hardware, DAL-B. We have another FPGA. It's a counter FPGA. It's hardware, DO-254, level A. And we have software, subject to DO-178, and it's DAL-A. So these are our 4 items that comprise our avionics passenger counter. If we were to edit these, you would see a number of fields that are open to editing. I'm going to give you a quick look at what it would be like to create a new item. So if you are a project manager perhaps, or the team leader for one of these types of items, you would have the credentials to be able to create a new item. Let's just make something up here. Let's call it a software input-output module. Okay. The type of item would be obviously DO-178 airborne software. We might want to give it some kind of identifier. Let's call it software IO. That's nice and easy and descriptive. And then we pick our design assurance level. Let's say this one is DAL B. The implications of how you set this up kind of run through the project, and I'll point those out as we go. One of the things we did here was we created the identifier, and that identifier becomes a prefix for various types of objects that get created that are associated with that item. Now these, you can override all of these, but the tool creates basically generic ones that are tied to the item and the type of object that it is. So in this case we use software IO, the identifier, as the prefix tied to -HLR to describe high level requirements. Same with low level requirements, model files, source code, test cases, and test procedures. So all of these get set up here by default. They are done so in a way that makes sure that there's no duplication in naming or numbering across items. Again, you can override them, but it's up to you to make sure that there's no duplication if you do change what the system creates. So this is how you would create your hardware or software item. Now I'm not going to do that right now, but I just wanted to show you how that could be done. Again, we can use this menu up here, same items as the buttons at the bottom of the page. So I'm just going to go back to my software list, my software and hardware items list, and that's the end of this demo. In the next demonstration, I'm going to be stepping through each of these navigation menu items here to describe exactly what's done and to show you how the tool operates on this type of data.